Here in problem number 6, we're asked to find the distance traveled by some particle moving along a straight line, the x-axis, from the time interval from 0 to 3. Remember that if you integrate a velocity function on a closed interval, we'll get a displacement. In other words, we'll get the distance that our particle ended from the location where the particle started. If you integrate the absolute value of velocity on a closed interval, we'll get the distance traveled by this particle. Now, sometimes you can get away with forgetting the absolute value bars depending on the function. Let's get started here. There's a few ways to look at this. Here's one way. The velocity is 6t minus t squared. Well, if you want to see when the velocity is 0, if you want to see when this particle changes directions, we can factor out a t, and with the zero product property, we'll get t equals 0 or t equals 6. Actually, 6 minus t equals 0, which leads to t equals 6. So if we were to, we should check for other critical numbers. When is this velocity undefined? Well, a power function is never undefined. But we're just having this conversation to review some topics with you. So if we were to go make a velocity sign chart, our critical numbers are 0 and 6. Now we can fill out the signs. Let's take x equals, or t equals -1, for example. Well, that would give us a negative times a positive, which is negative. We can put time equals +2. That will give us a positive times a positive, which is positive. Then we could put 7 in, and that will give us a positive times a negative, which is negative. Now you notice the interval that we're supposed to work with is 0 to 3. Our velocity is positive everywhere from 0 to 3. So don't really have to worry about the absolute value bars. The distance will be the same as the displacement of this particle from 0 to 3. That's one way to think about this. Another way to think about this would just be to sketch a graph of the velocity function. So the velocity function is 6 times t minus t squared. So if we put 0 in place of t, we're going to get 0 minus 0. There'll be a point at the origin. If we put 1 in place of t, we'll get 6 times 1 minus 1 squared, which is 5. Now this is not drawn to scale. I'm just going to estimate 5 to be about there. When time equals 2, 6 times 2 is 12 minus 2 squared, which is 4. 12 minus 4 is 8. So when t is 2, the velocity is 8. So we'll estimate that to be around here. And when t is 3, we'll have 6 times 3, which is 18, minus 3 squared, which is 9. I'll estimate it to be here. Now, if you see this graphically, we can see that the entire region that we're dealing with is going to be the sum of a bunch of y values, positive y values, that is. So we don't need to worry about the absolute value here. Our function is positive on the entire interval from 0 to 3. That's another way to look at it. Either way, we're going to integrate. So remember, to integrate, we can use the power rule. We'll get 6 times t squared over 3 minus t cubed, 6 times t squared over 2 minus t cubed over 3. We don't need the arbitrary constant because we have a closed interval. From t equals 0 to t equals 3. Just to remember that 6t squared over 2, that's just 3t squared. And t cubed over 3 is the same thing as just 1/3 times t cubed. All right. Fundamental theorem says we'll evaluate with the upper limit of integration first, putting 3 in place of t squared. So 3 times 3 squared is 3 times 9. 3 times 9 is 27, minus 3 cubed, which is 27, divided by 3, which is 9. And then we'll put the lower limit in. 3 times 0 squared is 0, minus 0 cubed divided by 3 is 0. 18 minus 0 is 18. So the answer was option letter D. Now, we had a lot of discussion in this problem. Just to review some concepts with you. Hopefully this helped you clear things up. When it comes time to take your big test here in a little bit, in a few weeks, hopefully you know this material well enough that you won't have to go through all those thoughts. You can just get to work on a problem and use your time efficiently. Well, hopefully this was helpful. Thank you for watching.